Another example is telephone or microphone. In telephone or microphone, we have sound signal which is getting converted into electrical signal. On the receiver end, this electrical signal is further changed into sound energy. So these are various examples for the transformation of energy or conversion of energy from one form to another form. Now we come to the law of conservation of energy. So what is the law of conservation of energy? It states that the energy can never be can neither be created and nor be destroyed but it can be transformed from one form to another form. So this is a statement of law of conservation of energy. Now we come to the conservation of mechanical energy. For the case of freely falling objects, so let us draw a diagram. This is earth or ground level. Or this is point C. This is some height h above the ground level. This is point A. Suppose we have an object whose mass is m and it is placed at height h above the ground level. So it is falling freely and it is dropped at this height h. So during its journey it comes to say another point which is B. This point is B. The distance of A to B is x, and so the distance from B to C is h minus x. Now, in this case we will prove that the total mechanical energy of this object is always conserved. It is same at all the points of its journey. It is same at point A, B and C. So, first of all we will find energy, total energy of object of mass m at point A. Now, at this point A, it is having mechanical energy. So, mechanical energy is of two types, potential and kinetic energy. So, total energy is either potential energy plus kinetic energy. At the point A, the particle or body is at rest. So, its initial velocity is 0. It is now it is dropped from point A. So, it is given its velocity is 0, initial velocity is 0. At point B, its velocity, it is having some velocity which is VV. At point C, its velocity is Vc. During its journey, it is gaining the velocity. Now, the potential energy of this body at point A is, now we will have potential energy at point A, this is kinetic energy at A. Potential energy at point A is equal to, as we have taken this object from the ground level, so the energy stored is mg into h, where m is the mass of the object, g is acceleration due to gravity. The value of g for earth is 9.8 meter per second square, and h is the height at which object is placed. Now, we come to the kinetic energy at point A. The kinetic energy is equal to half m. M is the mass of the object and its initial velocity is u square. At point A, u is 0, so the kinetic energy is 0. Now, total energy at point A is equal to potential energy mgh plus kinetic energy 0. So, we have total energy which is mgh. So, this is our first expression for the energy. Now, we will find the total energy at point B and at point C. Now, total energy at B is equal to potential energy at point B plus kinetic energy at point B. In this case, the height at the point B, height of the object is h minus x. So, we have potential energy mg h minus x plus velocity of object is vb. So, we have kinetic energy half m into vb square. Now, we have to find the value of velocity vb. This we can find from the equations of motion. We have an equation v square minus u square is equal to 2g 2as. V is final velocity of moving object, u is initial velocity, a is acceleration, and s is the distance moved by it. At point B, velocity is vb, so mVB² minus initial velocity at point A is 0, so we have u0 is equal to 2. The value of A is g, acceleration due to gravity. S is distance moved by the object, this is from A to B, this is equal to x. So we have mVB² is equal to 2g x. We can put this value here. So we have mgh minus x plus half m into 2gx. If we solve it, we have mgh minus mgx. 2 is cancelled out with 2, so we have mgx. So again it is coming mgh. The total energy at point B is again mgh. This is our expression second. Now we will find the total energy of the object at point C when it comes to ground. At point C, the total energy is Tc. This is equal to potential energy at point C plus kinetic energy at point C. So potential energy at C. Now at point C, the height is 0, so we have mg into 0 plus kinetic energy is half mVC². Here we the velocity at point C is vc, so we have put the value of velocity as vc². Now we will find the value of this velocity vc. Again we will use this equation of motion, b² minus u² is equal to 2as. So we can write vc² minus 0². From A to B, A to C, the total distance moved by the object is h. Initial velocity at A is 0. At point C, final velocity is vc, so we have vc² minus 0² is equal to 2gh. vc² is equal to 2gh. So put this value into this expression. We have mg into 0 is 0 plus half m into 2gh. 2 is cancelled out. So here we have mgh. So this is our total energy at point C. This is equation number 3. First equation was total energy at E is mgh. So this is clear from these three equations that whether the body is at point A, B or C, its total energy is always constant. It is not changed. Now we will solve some examples. A mass of 0.5 kilogram is dropped from a height of 100 meter. Calculate the amount of kinetic energy gained by the body the value of G is given 9.8 meter per second square. So its solution is, in this case we are given the mass 0.5 kilogram, the height is 100 meter, the value of G is 9.8 meter per second square. This is ground earth, this is height h. The object is dropped from this height to ground level. At this point u is 0. So whenever it is at height h, it is having potential energy which is mgh, and when it reaches to earth, this potential energy is changed into kinetic energy. This is equal to half mv². So we have potential energy at any height h is equal to kinetic energy at earth. So this kinetic energy will be equal to m into g into h. M is 0.5, g is 9.8, h is 100. So we have 490 joule. So this is our kinetic energy. So that's all for now. Thanks a lot.